We're thinking about the Earth and Life topic, and we're specifically looking at carbon sinks, how carbon can be managed, and how places like this that look so unpromising can be so important for reducing atmospheric carbon dioxide. There are 7 major stores of carbon on Earth. There's, as we can see here, soils is what we're interested in today, which includes peatlands. 2,300 billion tonnes or gigatons of carbon are stored in those areas, more than all the carbon that's stored in every plant on Earth. Peat is a kind of soil, but it's got very high carbon content. You can see here that there are rootlets and parts of plants which are only partly decayed. A peat soil has more than 60% carbon, and the carbon is what gives it its very dark colour. You can also see horizons here in the soil, in the peat soil, and you can see it's a dense mat of only partly decomposed vegetation. Peat soils are very important sinks for both carbon and water, and this is where the carbon cycle and the water cycle interact in a peat soil. Peat soils are ones in which we have an input of organic matter which greatly exceeds the output. And there are a few reasons for that. In high latitudes, like where we live in the Northern Hemisphere in the UK, we have, in Scotland for example, very low rates of plant breakdown, and that's because we have low temperatures. So the vegetation which is dying is adding organic material to the soil, and it's not decomposing. It's being buried, and often it's being buried where there's very little oxygen because the soil is also very wet due to high rainfall. So slow rates of decomposition due to low temperatures and water in the soil means that the organic material, the input of organic material, is very large. That rate of breakdown is affected by the water cycle because we have high water table and high precipitation. In northwest Scotland, we also have low rates of breakdown. Peat soils also develop in tropical areas, where there are actually high rates of decomposition, but the rate of input, the rate of plant death in those areas in tropical peatlands is very high. So trees and vegetation is constantly adding to the organic carbon content. So the input exceeds the output over here. So a peat soil is one in which the input of organic matter is greater than the output due to erosion or due to decomposition or soil respiration. So you might be thinking, I've never heard of peat. I don't think peat can be so important. In fact, it's extremely important. 175 countries have peatlands, and they cover around 3% of the total world surface area. 0.37 gigatons of carbon are stored globally in peatlands, and it's the richest store of carbon in soil. However, there are problems with peat because peat is being cut and harvested. If you dry the peat out, you cut it and harvest it, and it dries out, then you can burn it because it's so high in carbon. Even if you think you've never heard of peat, you might have seen it in this form, used in gardens to increase productivity. It's cut from areas like this peat bog in Ireland, and at the very top layer is a very important vegetation which is called sphagnum moss, and that sphagnum moss retains water and it prevents the peat from drying out. Peat has a very widespread distribution in Scotland. Here you can see the flow country, an area of flat land where peat is accumulating to the depth of about 2.5 metres. So as part of the OCR specification for Geography A-level, we're going to think now about the interaction between the carbon cycle and the water cycle for the peat soil. So first of all, we start off with the carbon cycle. Photosynthesis will enable the sphagnum moss to grow. This bright green moss which is growing here will grow on the top of the bog. Sphagnum moss is unusual because it can hold 25 times its weight in water. It traps all available moisture. It acts like a mega sponge, and when it does that, it is altering the water balance of that area and making it much, much wetter. So the bog moss will build up, and wetter conditions then will attract more moss to colonise. So the moss itself, which is growing and adding water, then changes the environment and adds to the colonisation of more moss. Increased volume of moss and partially decayed moss, more vegetation, that vegetation will die, and that they will then feed into the supply of carbon to the upland peat bog. So sphagnum moss and the growth of moss controls both the supply of organic carbon to the peat soil and also affects the water balance of that area. We've established that peats are key sinks, but there is a problem. They are being drained, they're being cut for fuel, they're being deforested, and then the whole soil is being burnt, or they're being converted to agriculture. Starting here, the peat bog is being managed by being cut, removing organic matter from the soil. What will be the next effect? This will then result in less photosynthesis, less moss. You can see here the peat is removed from the surface. Less carbon is stored in the vegetation and the soil layers. Because there's less moss, there's less water retention. Remember that sphagnum moss holds 25 times its weight in water and changes the water balance, raising the groundwater table. As this happens, we get a lowering of the water table, and the peat bog will then dry out. As it dries out, the carbon will come in contact with oxygen. When it does that, it will oxidize rapidly and decompose to carbon dioxide, which is then released into the atmosphere. We also get wind and water erosion occurring, but the main effect is oxidation of the carbon to form carbon dioxide going back into the atmosphere. So if peat bogs are disrupted, their water balance and the water table can change in that area, and there can be a complete reversal of the storage of organic matter. So they no longer act as a carbon sink, but they're acting as a major carbon source. So one of the global concerns about carbon dioxide in the atmosphere is coming from Indonesia, from the mega fires which are occurring in the tropical forests of Indonesia. Some of these are naturally occurring, but some of them are happening illegally as land is being cleared and deforested for soya plantations. You can see here an image where the forest is above and it's caught fire. Problem is that the soil is not like a normal soil, it's a peat soil, and it may be up to 3 to 4 meters deep. So the forest catches fire, but below it also the organic carbon in the peat also catches fire, and this leads to huge fires which are occurring in Indonesia and augmenting an already increasing carbon dioxide emission rate from that country because it's also an industrialising country. Peat bogs and peatlands have become the focus of management strategies. So in the Northern Hemisphere in Scotland, the management strategy has been to restore peat bogs. And they're restored by blocking the drains and trying to return and raise the water table to increase the storage rates of carbon. And there's a lot of money which is going into that. So recently, in June this year, 11 million extra pounds of funding has been added to try to restore peat bogs in Scotland. And the way in which that's taking place is many scientists across the world are working to try to check and monitor do these measures work. So here is a barrier which is stopping the water from draining away. It's stopping the movement of water, and it's trying to trap water here behind this barrier and trying to build up sphagnum moss, which is going to form here and increase carbon storage in this bog which had been drained. This is being measured, and it's being measured not just from satellite imagery, but it's being measured using carbon flux towers. It's very important that scientists can actually measure how much carbon is being captured. Also, in lower latitudes in Indonesia, there is also measures to try to tackle and manage the peat bogs, manage the carbon cycle. So here, the Paris Agreement, Indonesia signed up and pledged to reduce its emissions by 2030 compared with the business as usual scenario. And Indonesia have also submitted plans to the IPCC, and those plans of how they're going to meet the target include Here are some resources for further research should you be able to undertake that. To review the presentation, peat stores 0.37 gigatons of carbon dioxide. Peat is found in high latitudes like Scotland, where decomposition pathways are very slow. Peat is also found in low latitudes like Indonesia, where the input of dead organic matter is very high. Peat is a key carbon sink, and it covers 3% of the land area. Peat was only recently recognised in the 1980s as being really important for the global carbon and global water cycles. Human activities are affecting emissions from peatlands. Cutting, burning and draining all affect both the carbon and the water cycle. And finally, most importantly, don't forget, Mr. Moss. Sphagnum moss is extremely important. It stores 25% of its weight in water. It alters the water balance in those areas, raising the groundwater table and trapping water in those areas, allowing carbon to build up and to be a key sink in our high latitude areas.